So welcome to the next lecture as part of the Language of Empowerment series. And today it's my great pleasure to introduce our speaker, soon to be Dr. Kacper Łodzikowski. Kacper Łodzikowski is the Vice President of AI Capabilities at Pearson, where he leads a team dedicated to developing educational products using natural language processing and computational psychometrics. His work emphasizes designing human-machine interactions and ensuring ethical AI management. Kacper is recognized as a top executive in the AI field, having been listed in the prestigious AI 150 list for his leadership in AI-driven transformations. Alongside his industry role, Kacper Łodzikowski is a lecturer in artificial intelligence at our faculty. He teaches both introductory AI seminars, but also advanced courses for AI professionals. His dual expertise in industry and academia brings valuable insights to the responsible and innovative use of AI in educational settings. And today, Kacper Łodzikowski will deliver a talk titled Challenges of Implicit Bias in AI Towards Awareness and Mitigation. So Kacper, the floor is yours.
Hey folks, thanks so much for taking the time to join us. This is one of those topics where, as someone who builds and evaluates AI systems, this is the most challenging one. So I'll show you some things, but I'm most importantly looking towards the discussion at the end, because I would love to hear your feedback and your thoughts and comments about this. I structured this talk in 3 parts. First, I wanted to tell you just to give you an overview of where we are and how we came here when it comes to AI systems. And I like to think about AI systems in 3 or 4 waves, depending on how you count. So wave number 1, where these systems that existed from the Second World War up until pretty much the mid-80s. So these were the rule-based AI systems. What you see here is a well-known example. It's a chatbot therapist from the mid-1960s called Eliza. You can still play around with it online. There's a simulation version available. It was a very simple system that operated on a set of tricks, really. So what you see on the left, these are the example rules. And what you see on the right, this is the example chat, which I had with the system today. That's an example chat. And you see that the system operates on, it can understand the human language to the extent that it can parse this, it's syntactically. And it doesn't really understand the meanings of words, but it can manipulate nouns and phrases. So if I speak about my wife, it may just turn it into a conversation about a family, and you'll see that it will just try to regurgitate what I told it. There are, these kinds of systems are not really used that much these days. There are places where they are used for immigration checks, for credit risk scores, but for the most part, we've moved on. We will, however, talk about the challenges when it comes to the bias in these types of systems, because you will see later in this talk that there's a fundamental challenge when it comes to setting rules for AI systems. The most basic challenge that you saw in this Eliza example is, on the one hand, it's just a pretty simple set of rules. On the other hand, human biases are reflected in the formation of those rules. And various researchers argue, created frameworks for how to manage this. One example from Perez Escobar and Sarakia is that we need to look at 2 sides of, 2 examples for alignment. One is the alignment from the side of the humans, so what humans need to do to align with AI. And the other one is what machines should be able to do or would need to do to align with human values. On the example of something like Eliza or another rule-based system, From the side of humans, ideally we would have a diverse team which agrees on the outcomes for a system and agrees on how to write up rules and make sure the set of rules is comprehensive and not mutually exclusive and applies to a wide range of contexts. In practice, we know that's impossible, and we know we don't have to delve into AI systems to know that this won't work. We can stay within the field of linguistics and philosophers such as Ludwig Wittgenstein, who in his late philosophy said that we cannot really define the meanings of words, we cannot really model a language because it depends on how humans interact with each other and how they use words, and that's what defines the meanings of words and the rules of language and the rules of social interactions. So there are attempts at designing rules here and like frameworks for how you should write up rules, but there's a fundamental tension here, which we'll get back to later. I like to think about the second wave of AI systems that came, that started in the mid-1980s and lasted, or pretty much up until the very recent times, which we can call data-driven systems. Some people would call them machine learning systems. There was still an aspect of expertise in these systems. And what I'm showing to you is an example from what I deal with professionally, which is building systems for education, understood very broadly. In this case, it's an example system for automated essay assessment and feedback. It was designed back in the late 1990s, and it operated on this principle that if you collect enough examples of annotated experts, essays annotated by experts, just like you and I would do, the teachers in the room would do quite frequently, spending weekends and late evenings annotating essays. If you collect enough labeled data, then if you pass it on to a set of algorithms, you can pretty much teach the machine or allow the machine to learn on its own how to mimic your scoring and your assessment. Because if you think about it, even if you reflect on how you score the very first essay versus how you score the 50th essay, you have a very particular way, you have some implicit assumptions for what you do when you score an essay and then how you score the next one in the series. So what you see on the right is an example user interface from a system which is still in operation till today, which allows you to get feedback on a piece of writing, which is not 100% correct always, but it's the next best thing is if the teacher is not available and you just want to practice rewriting an essay. If we go a step further and look at I'll treat wave 2 and wave 3 together because they share the same set of biases and challenges. Wave 3 is very similar to wave 2. The fancy word, the professional term that people in the AI community use is deep learning, which is like machine learning, but using deep neural networks, so more advanced algorithms. And the difference is that in this case, in this wave, you still needed to more or less be an expert in the domain. So you would need to understand what assessment is, how you design assessment experiences, what features you need to pick when it comes to assessing an essay, and so on. And in this case, on the example of recognizing handwritten digits, you don't need to know that. You just need to collect a data set, make sure every digit image is labeled. So this one, the file would say 6, and you pass it on to a neural network, and what you get is a system that learns how to recognize digits without any domain expertise. So you don't have to specify that in order for the system to recognize a 6, it should look for a squiggly pattern. There's no human intervention in this case. There is still a labeled, annotated data set. And the challenge with these two ways of AI systems is that they are very widely used these days. And just sticking with the example of image recognition and classification, the challenge here is that on the one hand, they are quite scalable, so you can apply them broadly because you don't have to specify rules that much. The focus is on the data. But on the other hand, if you select a data set without really understanding whether it correlates to the use case you're solving, or if the data set contains mislabeled images or other type of bias, then that will lead to problems. What you see on the right is a famous Google flop where one user reported that his images, and of the images of him and his African American friend were mislabeled as gorillas. And what you should do in this case is either make sure you add examples of probably both gorillas and African Americans data set. In this case, Google did a very interesting thing. They didn't actually fix it. They just removed the label from the system. So up until this hasn't been really fixed up until today. This is from 8 years ago. So in Google Photos, if you input images of gorillas, they won't be labeled. They won't have a label. Which is, I would say, probably a cop-out from Google's side. Other examples, well-known examples are, if you, this has been sort of fixed over the past couple of years since these systems became more operational, but examples still persist. So these are older examples, but similar examples you may still encounter where facial recognition systems don't work well on African Americans. And this is a well-known example from a young picture of Michelle Obama from this is from 4 years ago, where she was mislabeled as a young man wearing a black shirt, whereas the shirt is yellowish, and wearing a wig, whereas I imagine that this was her real haircut. And examples like where black people put a white mask on, and then the system suddenly recognizes the face, otherwise it wouldn't recognize it. Or racial soap dispensers which respond only to a particular color of skin. So these are examples where if you have a team which is not diverse and that works on an AI system or a robotic system, then you end up with those implicit biases that you haven't even thought about. And there are solutions for solving this. What teams that develop AI systems usually do these days is they run more advanced checks on bias before they even publish a system. And even if they publish a system, they provide what's called a model card, where you outline how the model performs, what are the known issues, where you should not use it. And frequently what big tech companies like Amazon and Google do is when they offer these managed services for facial recognition, they have a set of clauses there, for example, saying this cannot be used for facial recognition and profiling by the police. So if the police wants to use it, they have to have a separate contract with the big tech company that will be managed separately, and bias will be handled separately. And this is very prevalent. Up until today, worldwide, there are still regular cases of people being apprehended or arrested because because their facial recognition algorithm at an airport or elsewhere recognized or miscategorized them as someone who is a felon, for example. And then we move into this more recent example, which many of you are familiar, which is this final wave. This current gen wave of AI systems, generative AI systems. And what you see on the screen is an example of how these types of systems learn. So there's the difference here is that whereas in the previous case, you still you had data, but the data was labeled. So at least the machine kind of knew what's quote unquote correct or incorrect, what's a 7, what's a 6, what's a cat, what's a dog. It was just the issue was with the data, that there wasn't enough data of a particular kind, not enough gorillas and so on. And in these types of systems, the neural network, on the example of this book, it reads a book a couple of hundreds of times, and at a certain point it actually starts to, it learns how to generate human-like grammatical structures. And you will see where punctuation appears, you will see where word-like structures appear, and if you repeat this enough, even on a single book, then you'll get a system that kind of generates human-like sentences. They may not be, they may not make sense, but they will be grammatically correct for the most part. And the challenge with these systems is we're just learning really as we start to poke at these generative AI systems, large language models or LLMs, we're just starting to learn what is it really that they do and how they operate. And because most big tech companies don't, on the example of OpenAI, which is quite closed because they don't really say what data they used for training a given model, we don't really know what assumptions to make about how a model behaves. So in this case, in the case of GPT-3 from, that's 4 years ago now, time flies. And most of this has been fixed in newer versions, but this was GPT-3, a study from 3 years ago, which showed that depending on which, how you characterize a person who enters into a bar, if it's a Muslim or a Christian, the completion of that sentence will be vastly different. And in the case of Muslims, it will be predominantly violent, usually. All right, so I wanted to focus on, in the second part of this session, I wanted to focus on those Gen AI systems, because this is really something that you all interact with probably on a daily basis these days. And it's only going to increase. I mean, these systems are taking off. So I wanted to help you understand how do we get to the place that you can interact with something like ChatGPT or Gemini? So the way these large language models or LLMs learn is, without human supervision. So the AI model, quote unquote, reads a vast collection of texts. Usually it's Wikipedia plus some book corpora plus millions of websites and maybe some other supplementary data sets. And that's what gives it this ability to produce human-like language. And then you have experts. Once you train a model, which takes a couple of weeks, a couple of months, it's a multi-million-dollar effort. You then have humans who try to add extra layers on top that make this model more aligned. And just to give you a quick understanding, so when these systems learn what words mean, they don't learn it from dictionaries. There were probably dictionaries in the training data set, for sure. But what they try to do is just group words into similar clusters and make some assumptions about word meanings. So again, purely following a Wittgenstein-inspired framework where you look how a word is used in a sentence and then you make some guesses and assumptions about what this word means and what the characteristics of this word are. And the reason these systems that, when you ask ChatGPT to translate something, the reason it knows what translate means, what the act of translation means, it's because it has seen examples of translation in the training set. So this is a paper about GPT-2 back from the time where OpenAI would still publish technical papers about their models, which shows examples of the act of translation from the 45 million websites that they used to train GPT-2. And it shows you examples from books and from forums and other sources which help the model understand what humans mean when they ask for a translation. And the main challenge, I think so far this is really the perfect way probably for an AI system to learn, just observe humans and observe and ingest as many artifacts of human interactions as possible. Where this starts to break is when these models try to generate something. And the challenge here is that they produce their outputs word by word or token by token, which would be a subpart of a word. And if you think about autocomplete on your phone, that's kind of how it works. You type the first word, which determines what the second predicted word would be, and so on. So if you think about, this is an example from GPT-3, so it probably will work better if you use GPT or ChatGPT with a newer model. This is where things start to break. So when I asked GPT-3, or when I give it this sentence, when it comes to consonants, English has ... And then we see a couple of completions, a couple of examples of how GPT-3 responds. And the first word that it produced was 21. And then you see what the other options were. So it actually produced options which were, were closer to the correct answer. But for some reason, it picked 21, and then it just went from there. Because it said 21, it needed just to produce 21 sounds, and then actually in some cases it produced graphemes, not phonemes, really. So it was that's another hallucination. And in other cases, it will give the correct answer, but then it will actually list fewer sounds than 24, and actually will omit some sounds and add some other sounds which don't exist in standard varieties. So that's, and this is, again, despite the fact that if you really poke at the model, as researchers do, you will see that it more or less has acquired the collective intelligence of us in the room, and it is at or above the level of a typical PhD student at this faculty when it comes to linguistic awareness or reasoning capabilities or just the ability to process data. And there were many tests that people ran on phonological, syntactic reasoning of these systems, and they actually they excel at this. And this is really where we get to this point where if you take such a model which has this propensity to hallucinate because it outputs sentences word by word, this is where you get to these examples which people talk about in the media, which will start affecting us more and more. So again, this is my example. So I started this sentence by saying, I study computer science at university, just like my ... And then these were the options that the model considered. So brother, 33% probability, father, older, and then sister was down low. That's probably, again, because in the training data, whatever that was, we don't know, computer science jobs were probably associated with males. And that implicit bias, willingly or not, so like the designers of the system assumed, make an assumption about this. This bias is now perpetuated in the output of these new models. And in fact, and the challenge here is that it doesn't get better over time. What you see on the right is a table from a very recent paper from Meta. And you can say what you want about Meta, but we got to give them credit for actually promoting open source research on AI, and they publish a lot of open source models, which allows researchers like ourselves to actually better understand these models. So I highly recommend research from Meta. I think it's good quality. So one of their research papers on one of their llama models showed that the difference between a model from 2020 and 2023, so 3 years of research and development, is not that big actually. Like the average toxicity, higher score is worse, pretty much has not changed significantly. There are differences between categories, but overall, these models are not really, haven't really improved when it comes to all sorts of bias. All right. What usually happens when companies like Meta and OpenAI work on their assistants, so what I showed you was, GPT-3 is just the base model. That's what people, that's the, if you ask GPT-3, if you try to have a chat-like conversation with it, it won't work. It'll just complete sentences because it hasn't been fine-tuned. There's no extra layer for it that kind of shows it how to behave as a chatbot. So this is this base model, and what happens at the final stage of developing a language model so that it behaves like a chatbot or like an assistant you can have a conversation with is this sort of supervised alignment, another fancy word from the world of AI. So alignment means how we adjust the behavior of the system so that it behaves in a way according to human preferences and values. We'll look at this in a second. So there are a couple of ways of doing this. I'm just showing you 2 examples. What you see on the left is a pretty standard, and in fact, even if you look it up now, whenever a company like Meta or Google release their models, open source models for you to download and use, they will usually have a couple of variants of them. And they will say, this is Llama 3 base model, and another one will say Llama 3 instruction tuned, which means it went through this process of instruction tuning, which means that on top of reading Wikipedia and all the books and all the data sets in an unsupervised manner, so without human intervention, there was a second stage where subject matter experts created a smaller but a more curated, high-quality data set that showed to the model examples of human interactions in various situations, so that we can kind of guide the model to behave in an assistant-like manner, so that humans can interact with it in a safe in a safe way, and in a way which, again, is aligned to human expectations of the conversation. And what you see on the left is just a snapshot of such a data set where you will have a couple of examples of giving advice, and you will have a safe example and an unsafe example. What you see on the right is another way of this fine-tuning, which sometimes actually happens while a model is already operating on production, and this is called reinforcement learning from human feedback. And in fact, you've probably helped companies like OpenAI and Google adjust the behaviors of their models according to your preferences. If you've ever clicked on the dislike button, or what they do now is they have another trick, because they give you sometimes they give you two options for you to choose from. That signal then goes back to a database, and it's not live or online updating, but every month or so they would take all this data set and take whatever new version of GPT is about to come out, and just use these preferences. They take your queries, what you asked the model to produce, and whether you gave it a thumbs up or thumbs down, and they say, okay, model, okay, AI, look at what Grzegorz really, the particular type of haiku that Grzegorz preferred, or the particular type of recipe that Robert preferred, and kind of try to do more of this. And this is already where we are getting probably in equal measure good signal and noise, because human preferences vary, and making sense of all of this is not trivial. Okay, I wanted to move on to the final section, where it's formulated as a question because I don't have an answer, and I'm not so sure. But let's try. There are a couple of good frameworks that have been developed very recently for thinking about development of future systems, future generative AI systems. And again, this applies to image generation, but let's focus on language models and those chat-based systems that you interact with on a daily basis. This framework is called RISE. I actually quite like it, and it has two main parts. It's not as complicated as it looks. It has two main parts. So the two types of alignment you do. One is forward alignment, and the other one is backward alignment. So forward alignment is everything you do, kind of like I just showed you, at the stage of developing a model and you're monitoring its behavior before you release it to the public. And backward alignment is once you've released a model, then all the things you can do as a creator of a model or an AI system to help others evaluate it, to help third parties audit it, to help to work with governments on creating frameworks for operating AI models in a country in a way which puts some constraints and increases the safety of those models without thwarting the entrepreneurial spirits of people who create AI-based solutions. So that's one way of looking at it. Another way of looking at it is how we should really think about values alignment. A couple of good examples, actually quite a lot of examples coming from the intersection of philosophy, the philosophy of language and linguistics, where people make those people propose to somehow, and that's the more tricky question, like on the engineering side, actually how to do it, people propose solutions grounded in our understanding of successful human cooperation. So Grice's maxims, different types of discourse. You remember a couple of years ago, Meta released a model which arguably was a flop. It was called Galactic and was supposed to be a model that helps researchers summarize summarize research papers and write new research papers. And it was actually criticized over its accuracy and also various types of biases, such as lack of objectivity. So one way to think about alignment of these models, if it's not realistic for us to write rules for how a model should behave, then maybe we can at least write some high-level principles and just let the model figure out. Again, have the model observe various types of scientific discourse and probably come up to this realization that it's about objectivity and transparency and so on. The same when it comes to the democratic discourse. This example from Microsoft from 2015, a chatbot which is deployed on Twitter and shut down after 48 hours after she went full Nazi on pretty much everyone. Because the chatbot relied on the input that was fed with. So when users started to troll it, to try to incite it towards violent behavior, it started responding with super violent behavior, and it needed to be shut down. And in this case, the idea would be that we need to somehow help the AI understand that in this type of discourse, the democratic discourse, there are certain principles of inclusivity, civility, and openness to ideas without criticism, without pushback. So it's a separate question as to how to actually build it. We don't yet know. And another question is, if this is a well-known example of someone creating a series of images where they asked an image generation model to generate an image of a professor of various discipline. And I'll ask you to decide whether you think this is biased or not. And then how do we decide, if we want to use image generation models, to help, maybe as classroom materials for conversations in English language learning classes, then how do we decide what's biased or not? Is if we take all the images from the internet and we use that as input to a model, is that then, there is some sort of distribution of images there, but is that biased? Or if we ask a couple of humans in the room to create rules for this system to behave, will that be biased? And then how do we select those humans? Some of this there has been some interesting research. This is a very well-known paper from MIT from a couple of years ago, which was focused on AI alignment for autonomous vehicles. And it's still online. You can still play around with it. It was like an online experiment where it was called the MIT Morality Experiment, where they asked people from around the world to just submit their preferences. Very easy, like this or that. And there were a couple of scenarios. So should you kill, the car needs to swerve. Should it kill 5 dogs or 5 robbers who happen to, escape, happen to be just crossing the road? They just robbed the bank and they are clearly baddies versus 5 puppies. Or in this case, which is more realistic, I guess, 5 grandpas or 5 grandpas. And you saw from the results that people from the southern hemispheres generally would prefer to spare the females versus the males. And again, that already is an interesting piece of input on values alignment to these types of autonomous systems. And just to wrap it up, there is actually a tidal wave of AI regulations coming up. China is actually leading on AI, both in terms of models and regulation. We didn't see that much. When I visited China and my AI colleagues recently in Beijing, I was quite surprised with their progress. And also I was surprised by how scared they are of making mistakes when it comes to AI, because they are actually held liable for, the developers are held liable for major mistakes, personally. In the EU, we actually have a couple of examples. We actually have laws such as the GDPR that actually regulate a lot of what we talked about. Just to give you a couple of examples. So these are very recent fines due to algorithmic bias, broadly speaking. So Trivago was fined for, Trivago is like a hotel booking website. It was fined for its model, which was not transparent to users. Even governments get fined. Even European governments get fined by, well, the European, the laws that they sort of agreed on themselves. This was a quite interesting case because that was, the Dutch authorities got fined for a couple of reasons, for using too much data, and also specifically on a model which was biased, which flagged individuals with dual citizenship. So Dutch, and I'm forgetting what the other one was, but dual citizenship as very likely of committing fraud for child benefits, like a very particular use case, which had practical implications for these people who got fined. And then Deliveroo, which I think is the UK equivalent of, like Pyszne.pl, that they got fined as well. For a model which was not transparent enough for the delivery people. And so in the EU, the clock is ticking already, and the EU AI Act, the big, quite stringent piece of regulation, was approved into law earlier this year, and it will enter into force for the regular people like us in 2026. But for some companies already later this year and early next year. And I quite like this model. It's a very simple model, which is it's a risk-based model. So you see that it very clearly shows that there are certain uses of AI which are allowed generally, so video games, for example. There are certain uses of AI which are prohibited, so facial recognition, just like we discussed. Although there are provisions for the military and the like. And then what I find interesting is that education is a high-risk AI use case. And this is still to be determined. So with my professional hat on, we spend quite a lot of times in the company I work for, working with Brussels and actually also other governments, especially the UK government, and trying to agree on actually how to interpret these high-level regulations. What is a high-risk use in education? So if we give you feedback on a piece of homework, it seems like a low-stakes situation. But then automated high-stakes assessment that gives you a foreign language certificate and decides whether you get a study visa in the US, that's something which has to be regulated. And the EU AI Act pretty clearly outlines what companies like OpenAI need to do, what companies like Pearson need to do when they use models by OpenAI, and then what are the provisions for the users, what are the rights of consumers. And I'll pause at this just to leave at least 15 minutes for question. I think maybe I'll finish with this slide. So one thing we can do is just to help everyone, our colleagues, friends, family, understand that this is happening and that this is not going to stop. The OECD measures quite regularly the levels of literacy in Poland, and they also include computer literacy these days. And the numbers for Poland are quite bad. If you look at this, 50% know how to copy a folder or a file, or how to edit the text. And this is basic computer literacy. So we don't even talk about how to interact with an assistant, ChatGPT style AI system, and what the dangers are of that. So if there's anything you can do after this talk, apart from thinking, well, there's nothing we can do about it, then probably the best thing we can do about it is just to continue the discussion and to help others realize some of these challenges and ways in which they can make conscious decisions as to whether they want to use or not use these types of systems. And I'll pause at this, and I would like to open it for discussion. And not only I'm super open to answer your question, but I would especially love to hear your thoughts on this and where do you think this is going and what we should be doing. Thank you.